Hi, everybody. We want to talk about simplifying expressions using the order of operations. Now, before we start, let's make sure we know the difference between an expression and an equation. Over here in green, we have an equation. I can tell because there's an equal sign. And what that means is that the quantity here on the left is equal to the quantity here on the right. And for me to verify that this is true, I would need to simplify this side of the equation. So I'm going to do that using the order of operations, and this one's quite simple. All I need to do is think about this as there's an addition problem and there's a subtraction problem. Immediately, I want to change the subtraction problem to addition of the opposite number. So what that means is that we won't ever have subtraction, and these are all now addition. I am going to, since I can add in any order, I'm going to choose to add just the positive number. So 2 plus 3 is 5, and to that I'm going to add negative 4, and all of that should equal 1. I'm going to keep simplifying this expression by adding these two things together, a positive and a negative. I notice that the positive has the greater absolute value, so my answer will be positive, and the difference between absolute value 5 and absolute value 4 is 1. So the answer is positive, positive 1, and of course that equals 1. So this equation is true. Now, to prove that this was true, I had to simplify the expression. Over here in red, oftentimes you'll just see the expression all by itself, and you're asked to simplify it just as practice so that you can solve equations. And basically you do the same thing. We'd say 2 plus 3 is 5, and we'd change that to plus a negative 4, and 5 plus negative 4 is 1. So when we're simplifying an expression, we're just sort of working downwards. Here's an expression written out from left to right, and as we solve it, it sort of gets simpler and simpler until we're left with 1 or 2 terms. An equation, you do the same thing on one or both sides. It's just that both sides should be, if it's a true statement, both sides would be equal to each other. Okay, we're not going to talk about equations for the rest of the video. We're going to talk about expressions. All right, let's keep going. So let's take a look at this. We've got 4 minus negative 5 minus 5, and people have had some trouble. And one of the biggest problems is keeping track of the numbers that are negative and the numbers that are positive. So what I'm going to ask you to do is just follow my sage advice, the words that I tell everybody, and that is, let's ignore or just turn our backs on subtraction. Every time I see subtraction, I'm always going to change it to addition of the opposite. So this becomes 4 plus. And now I have to think about what's the opposite of this number. What's the opposite of negative 5? 5. And I'm going to change this subtraction problem to plus. And what's the opposite of this number? What's the opposite of 5? Now, here's where you might get mixed up. This isn't a negative 5. It was minus 5, right? So instead of minus 5, we're going to say add the opposite, add negative 5. So there we go. And now you should be able to keep things fairly straight. I'm going to use the associative property to say these two positive numbers are going to go first. When you're adding, you can really work in any order you want, but it's better to kind of group the positives together first. And then when you're finally down to a positive sum and a negative sum, put those together. So 4 plus 5 is 9, of course, plus negative 5. And I'm going to think about the absolute value again. 9 has a greater value than negative 5, so the answer will be positive. There's more positive numbers than there are negative numbers. So the answer will be positive, and the difference between these two is 4. The answer is positive 4. Generally, we do not write the positive symbol next to numbers that are positive. It's just assumed that they are positive. All right, let's kind of keep going. We're going to look at some other things here. This one, we're asked to distribute. Okay, so this problem says 9, let me switch up colors here. This problem says 9 times the quantity 2 minus 8. So really this is a multiplication problem. It's 9 times something, you know, whatever's in these parentheses, and it's up to us to figure out what that is. So the first thing we should do though, right, before we get too far along, is to say that is 9 times 2 plus negative 8. All right, and now we can solve what's inside those parentheses, or we can distribute first. So just for practice, let's look at distribution. 9 times a sum, right? That's an addition problem. You can distribute that multiplication over addition. This only works with addition. right? We can't distribute multiplication over another multiplication problem. That's not how multiplication works. So this would be 9 times 2, which is 18, plus 9 times 8, which is 72. Now, what you just saw me do is what many students do. They just jump to the multiplication fact. It feels comfortable. They know what it is. And they forget about the negative sign. So let's back up a second and remember that you should always consider the sign first. 9 times negative 8, a positive times a negative, will be negative. And then just do your multiplication fact. 9 times 72, 9 times 8 is 72. Okay? Now, let's go ahead and add these two numbers together. The difference between 72 and 18, right? We're thinking about their absolute value here, and then we're going to find their difference. Now, I'm showing this because I often say subtraction is not a real operation, but we do have to use it when we find the difference between two absolute values. That's really the only time we use subtraction, right? So you can go back to your grade school days and think about how do you subtract. And we have 54. Now, we could just write the number 54, but again, we're forgetting the sign. That's why we should always do the sign first. So again, let's back up. Say to yourself, the 72 has a greater absolute value. That means the negative sign will dominate. So it's going to be negative. And then you can figure out the difference. And the answer is 54. There, we have simplified that expression. Okay, so that's distribution over addition. Remember, this only works with addition. Let's take a look at another problem. All right, this one is, we'll just do this pretty quickly. We'll write this as addition. We will write this as addition, right? Plus negative 4. And let's do something different. Let's try two different strategies here. I'm going to say negative 6 plus negative 4. If I do the parentheses first, just like in the old PEMDAS days, I would end up with negative 10 in the parentheses. And I still have negative 3 on the outside. A negative 3 times a negative 10 is going to be positive, and 3 times 10 is going to be 30. Let's look at distribution. Let's just see if distribution gives us the same result. Negative 3 times negative 6 will be positive. A negative times a negative is positive. 3 times 6 is 18. Plus 3 times negative 4. I should say negative 3 times negative 4. A negative times a negative is a positive, and 3 times 4 is 12. And 18 plus 12, of course, is 30. So you have an option. You don't always have to distribute multiplication over addition, but sometimes you need to if there's a variable inside the parentheses. All right, here we go. Let's try one more. This is good, right? I hope you waited till the end. I think there's a little mistake here. It looks like it used to be a 4. There we go. So what's interesting about this is there's just a negative sign in front of these parentheses. And we could think of that as the opposite of 4 plus negative 6. The opposite of 4 plus negative 6 minus 4. And we could simply do the parentheses first, but let's distribute this negative sign, right? We kind of want to get rid of this negative sign. We want to change it to the opposite. So we could change this to plus the opposite, right? We could add the opposite, but then we're in the same position of negative 4 plus negative 6. So instead of that, let's think about this negative as a negative 1, right? Plus 4, times 4 plus negative 6. And then we'll write the negative 4 right here. And this is what I mean by distribute the negative sign. We could think of this as negative 1 times 4, and it gives us a negative 4. And we could think of this as negative 1 times negative 6. And of course, a negative times a negative is a positive, so we'll write positive 6. And in this way, we've sort of gotten ourselves the opposite of 4 plus negative 6. We started out with this, the opposite of 4 plus negative 6. And we ended up with negative 4 plus positive 6. So when we distribute that negative 1, it gives us the opposite. All right, and now we can use our order of operations. These parentheses here they're left over, but we don't really need them anymore because there's no more multiplication to do. We're really left with negative 4 plus 6 minus 4. And of course, a long time ago, I should have changed this to plus -4. And now here, let's use the commutative property again. I've got 3 numbers to add, and I want to change these around so that I'm adding the negative numbers first. It will just make things simpler in the end. So a -4 plus a -4 is going to be -8. That's a lot of negatives. And I'm going to add my +6. The reason I wanted to move those around is because this is often, adding the 2 negatives together is not so much a problem. Where people run into a problem is when you're adding numbers with different signs. So try to save that for the end when there's only one of each kind left. So here we see -8 has a higher absolute value, so the answer will be negative, and it will have a difference of 2. So that is the simplified version of this. That all that up there equals -2. Great, I think that's it for this video.